Hi, I told you we're gonna move on to more challenging sums. We started with very simple ones, didn't we? Drawing linear, drawing quadratic, and then we went to 1 over x, where we talked about the line, the asymptote that you cannot cross. Alright? We'll have to think a little bit further into that as we move on to the more challenging problems. But you realize that curve sketching isn't that difficult, isn't it? And you will realize that as x changes, y changes. Alright? So they take different values. And also we look at the order now. I'm going to move the order from 2. Alright, we started with 1, 2. Now let's go to 3. What happens when y is 1 over x cubed? What's the shape of this graph? Now when x is 0, what is y? 0, right? So let's do a small little sketch where I'm doing it in a very traditional style, alright? So you get a deeper understanding. You know, they say that old is gold, alright? So let's take some points to see the behavior. Let's take x to be a minus. What number do you like? Let's take whole numbers, which is very easily workable. Let's take a minus 5, and then we take a minus 2, we take a minus 1, and then maybe you want to try something really small before we get to 0. X is like 0.01, fine, and then we take a 1, 2, 5. Let's see how x behaves with that. And then we can talk a little further and say, alright, how's this graph gonna look like? Now you see that when x is minus 5, I've always told you the importance of learning timetables, powers of indices. If you had done my indices module, you would have seen we know 5 cubed. What's that answer? Haha! Indices, power. 5 to the power of 3 is 1 to 5. Remember we had a joke, 1 to 5. So 5, x to the power of x is minus 5. The power of 3. Minus 5 repeated 3 times is still a minus. 5 times 5 times 5 is 1 to 5. Minus repeated 3 times is an odd number, 3. So minus repeated 3 times is negative. Minus 2 the power of 3. Just the way you write, minus 2 the power of 3. Minus repeated 3 times is a negative. And 2 cubed is 8. You tell me it's 6. I feel like Alright, remember 2 to the power of 3 is 8. Minus 1 to the power of 3, yes, it is a minus 1. Now we go to minus 0.01. Alright, what do you think it is? I want to put a minus here, but I missed out a very important number. I'll tell you more. If it's minus 0.01 to the power of 3, what is 0.001? It's 1 over 100, isn't it? So if we write it this way, 1 upon 100 to the power of 3, what will that be? It's minus 1 over a million. So this will be minus 1 over a million. Isn't that huge? Really, really small. Right. Now I wanted to put a 0, but I overlooked. And so let me write, because 0 is so important. How does y behave when x is 0? Alright, we always want to ask this question. When x is 0, x cubed, 0 cubed, this is a 0. Yep. And when x is 1, 1 cubed is 1, 2 cubed is 8, 5 cubed is 1 to 5. Now once we've got this table, a rough sketch, In fact, we can draw a more accurate sketch, more than a rough sketch, because we've got so many information. Let's get the axis right. Y equals to x cubed. We see a negative reading and a positive reading. As I told you, this is a sketch, so we're going to make it small because I need to have more space for more sums for you. So we get a 0, we get a -1, a -2, a -3, -4, and a -5. I don't like that. So I'm going to change because I don't have enough space. Let's do it again one more time. I said this will be a 2, -2, -4, -6. This will be a 2, a 4, a 6. Well, your 1 will be in between, 3 and 5 are all in between. Now, if you look at when x is -5, y is -1 to 5. That's really down. Alright? When x is -2, y is a -8. Let's put it here as a -4, -8. This is 0. This is a 4. This is a 8. This is a 12. A 16. Now look at it. If x is 0, let's start from here. Y is a 0, isn't it? And when x is -0.01, y is nearly a 0. Alright, just to tell you, it's the negative side of 0. When x is -1, y is -1. Somewhere here, x is -1, y is -1. When x is 2, y drops to -8. When x is 5, let's look at it. Ooh, it's dropping right down. Right down. When x is, so you can see the drop. Alright? When x is 1, y is a 1, somewhere here. When x is 2, y is an 8. When x is 5, y goes right up. So the shape of this graph is this way. Alright? I'm just doing a sketch. You can see I deliberately put in just a simple number of -5 because it has the power 3. Alright? It has just grown so big. Alright? Or it has gone right down to minus if you put a minus number. So the shape of y equals to x cubed is this way. Does it really have a turning point? Not really so. When you say a turning point, you have to have up, down, or down, down going down, and then up. That's a minimum point. A maximum point will be from down, maximum point from down going up, and then dropping again. That should be a turn. Do you see a turn here? Not so. You wanted to turn, but it did not turn at this point, 0, 0. So let me introduce this point called point of inflection. Alright, we call this point of inflection. It is not a turning point, wanting to turn, but not turning. And those of you who have done your calculus dy dx, right? You will see from the first derivative, dy dx, when it's 0, alright, you get a turning point, right? You're supposed to determine. But the second derivative is again 0. That shows you it's supposed to turn, but it didn't turn. So it's called point of inflection, if those of you have studied that. Alright, so this is the shape of the graph of y equals to x cubed. But what happens now if I put y as minus x cubed? Let's move back to the thing again, the chart, the graph. Now y equal to a minus x cubed. What happens? Is this is x cubed, a minus x cubed, this will be positive, minus and minus. Look at the x cubed, just make it positive. This will be an 8, this will be a 1, this will be a positive, 1 over, this will still be 0, but now x is minus x cubed, this will be a minus 1, a minus 8, and a minus 125. You can see the reverse, don't you see it? Alright, so the shape of the graph, I better write this name down, y equals to x cubed. But if it's a minus x cubed, when x is a minus 5, y is 1 to 5, right up there. And then when x goes down to minus 2, y is an 8. When x is 0, y is 0. When x is 2, y is 8. When x is 5, y is minus 1 to 5. So the shape of the graph goes like this. And this graph, y equals to minus x cubed. So what we were trying to do earlier on was we were trying to draw the graph of y equals to plus and minus x cubed. And what happened? We've got the shape of a positive x cubed. When x increases, y is increasing, right? Because it's positive x, y is x cubed. When x is 10, y becomes 1,000. When x is 100, y becomes 100 cubed. Yes, you know it, it's 1,000,000. So that's it. But in the case of y equals to minus x cubed, when x gets bigger, y gets smaller. You can see it. When x is 10, y is minus 1,000. But when x is a minus 10, because of this minus, you see the behavior y is a minus x cubed. When x is a minus 10, alright, minus 10 cubed. Look at that, minus repeated 3 times will be a minus. And a minus will give you a plus. So 10 cubed will be 1,000. So you'll see that when x is negative, y becomes positive because of the minus. Do you have a better understanding? And do you see the shape of x cubed? Right. Now we will move on to a little bit more on x cubes the next round, the next drill when I'm coming back to you again. I just want to give you a little bit more variety in curve sketching. Alright, let's move to exponential functions. What do you mean by exponential functions? Exponential functions alright, is actually when you have 2 to the power x, e to the power x. Any number, the power x is up. It's a power now. And how does x behave? Alright, so we're going to do a sketch on this, and we're going to do a sketch on y equals to 2 minus x, and see the difference in the behavior. Alright, let's do a simple one to have a better understanding. Y equals to 2 to the power of x. Let's get some tables here. We get x when x is minus, let's put it as minus 5, x is minus 3, x is minus 1, x is a 0. At this end, let me take 1, 3, 5. Let's see how y behaves. What is y again? 2 to the power of x. Now, y is equal to 2 to the power of x. 2 to the power of minus 5. What is it? Indices. If you learned it in the earlier drill or the later drill that you haven't got to it, you will get 1 upon 2 to the power of 5, isn't it? The negative power, which is 1 upon 32. Yes. So if you have minus 3, x is equals to minus 3. It's 1 upon 2 cubed. That is 1 upon 8. When x is minus 1. Look at it again. When x is a minus 1, you get 1 upon 2. You can see that the numbers as x is getting bigger, y is getting bigger. When x is 0, what happens? 2 to the power of 0. Any number to the power of 0 is 1. Remember, I told you the other time, you want to feel rich. Hey buddy, I've got 1,000,000 to the power of 0. Just say that softly, 0. I've got 1,000,000 to the power of 0. And walk away. Your friend will be thinking you're a millionaire, remember, but actually you only have $1 in your pocket. So here, 2 to the power of 0, you get a 1. 2 to the power of 1 is 2. 2 to the power of 3 is 8. 2 to the power of 5 is 32. What do you notice about this? Do you see any negative numbers? No. Your y is all positive, irrespective of your x. Even when your x is negative, your y is still positive. Is it only because we started at x minus 5? Fine, you want to take a more negative number? Tell me what number you like. Minus 1,000? Fine, let's try it. 2 to the power x is minus 1,000. What do you get? You get 1 upon 2 to the power of 1,000. You try it on your calculator, and your calculator will tell you error 2. You see the calculator, maybe if your calculator is quite advanced, they might give you a very, very tiny number, a very, very small number that's almost approaching 0. Do you see it? Alright? So what it tells you is that when x gets very small, when x approaches infinity, minus infinity, alright? When I say minus infinity means x is minus 1 million, 10 million, million, whatever you can say as a negative, y approaches 0. Alright? This is a very important point in exponential function. Take note of it. And also, when x gets bigger and bigger, when x approaches infinity, positive infinity, what happens to y? What happens if x is positive? Positive 1,000. Y is going to be, just imagine, 2 to the power of 10 is already 1,024. 2 to the power of 11, 2,048. Remember we studied that. 2 to the power of 12 is already 4,096. Imagine you're going to multiply more and more, 2,000 times. It's going to be so big. I don't know. It's almost infinity, right? So when x gets bigger and bigger, y approaches infinity. Got it? Hey, let's draw the graph now. So a very quick sketch. Things are getting easier now. This is y, this is x. Alright? Now when x gets very big, hugely negative, y approaches 0. When x gets bigger and bigger and bigger, y is rising. So the shape of the graph, let's find out, is going to be when x gets bigger and bigger, y is going to get bigger and bigger, and you can see when x is 0, y is 1. X is 0, y is 1. The shape of the graph is going to be like this. Alright? And this graph y equals to 2 to the power of x. Okay? So as x gets bigger and bigger, y gets bigger. You can see that when x is 5, y is 32. If x is, as I said to you, 10, 1024. If x is 12, 4,096. Just keep multiplying. Alright? It's getting bigger. So that's how an exponential graph is. Imagine if it's just 2 to the power of x. If I put it as 10 to the power of x, it will even be faster, the rise. Alright? And you will notice that in this graph, it does not cross this line. So this is called the asymptote, the y-axis, which is x is equal to 0. Alright? So take note of it. When it's an exponential 2 to the power x, right, it does not cross this line for this graph, and it goes on. Now, I hope you understand the shape of the graph, but I got to get to this. What happens if 2 is a minus x? Now you remember 2 to the power of minus x, right? All the negative powers of x. When I put a negative power, I'm going to write it down here. 2, I'm going to squeeze in, if you don't mind. Squeeze your eyes to see this. Can you? 2 to the power of minus 5. It becomes positive. It becomes a 32. 2 to the power of a minus 3. You get minus and minus becoming plus. 2 to the power of 3 is 8. 2 to the power of minus 1. You get a 2. Ooh la la, let's work it out. 2 to the power 0, 1. 2 to the power minus, there's a minus 1, you get a half. 2 to the power minus 3, you get a 1/8. 2 to the power minus 5, you get a 1/32. And that's how it goes on. So you can see the reverse behavior. When x is negative, because of 2 is a minus here, when x is negative, the negative and the negative makes it a positive. So if x is a minus 10, a minus and minus will make it a plus. 2 to the power 10 is 1024. So what does the shape look like? Here is this way, now it's going to be this way. Alright, and you know that when x is 0, y is still 1. So x is going to be like this, the shape of the graph is going to move. So this graph, y equals to 2 to the power of minus x. Alright, so if you look at it, it's 2 to the power minus x. It's going to get more and more steeper up, because this is what we call exponential. When somebody tells you, hey buddy, you've showed exponential improvement in your maths, you say, it means you're improving at a real steady rate. And I hope your curve sketching is improving at an exponential rate.